Hi there, I hope you are doing well. Today we are going to discuss about the Cauchy sequence and we will discuss about the Cauchy sequence and how to check that sequence is Cauchy or not. A sequence. So today we are going to discuss about the Cauchy sequence and we will discuss about how to check the sequence is Cauchy or not. See, so we have to check the sequence is Cauchy or not, and we are going to discuss about the Cauchy sequence. Okay, let's discuss about the Cauchy sequence. A sequence x is equal to xn is called Cauchy sequence. Cauchy sequence is called Cauchy sequence of real numbers if is said to be Cauchy sequence of real numbers if for all there is a epsilon that is greater than 0 and there exists a natural number h of epsilon that belongs to capital N natural number such that xn minus xm is less than epsilon for all n and m is greater than equal to h. So this definition is symmetric to the limit. It is like a limit definition. So Cauchy sequence are those sequence if xn is a Cauchy sequence. The sequence are called Cauchy sequences if the distance between their two terms is less than any positive number epsilon. If the distance between you can say if the distance between any two terms of the sequence nth term and m term of the sequence is less than epsilon, and the sequence in which these two terms exist whose difference is less than epsilon, then that sequence is called Cauchy sequence, and n and m are greater than equal to any capital number h. So let's discuss about that sequences. For example, we have a sequence and we are going to check that it is Cauchy or not. For example, we have a sequence 1 over n sequence we have, and we are going to check that it is Cauchy or not. So it is basically the numerical method, and I actually want to teach you definition through this method. So what definition is saying? Okay, we are going to discuss like that. Okay, for example, you know that epsilon is an arbitrary number, and in the definition of limit, we have also discussed that epsilon is arbitrary, and we can take any value of epsilon. We can take epsilon equal to 0.01 equal to 0.1. According to that, we have to select number. So let us discuss. If we open it, in this sequence, n belongs to natural number. If I put n is equal to 1, 2, 3, I will get the corresponding values. I will get the sequence like 1 over n equal to 1, 1 by 2, 1 by 3, so on. We will get this sequence like this. Okay, now we have to do what? So this is the sequence, and let us take an is 1 over n and am is another term 1 over m of the sequence, and let us take epsilon is equal to 0.01 because epsilon is arbitrary number and we can take epsilon equal to any number, so we have took it 0.01 which is greater than 0. So now we have to show that how this definition work. According to the definition, can we take any n or m whose distance is less than 0.01? If the sequence is Cauchy, then those n and m exist for all n and m is greater than capital N. Let's take the basically n and m according to our choice. Let us take, if I take, for example, I want to teach you definition. If I take n is equal to 101 and m is equal to 102, then the let put the value at the place of n 101 and the place of m 102, then divide them, and less than 0.01 or not. Let's check it. If we take n is equal to 101, m is equal to 102, then after dividing and solving, we will get 0.00099, which is less than 0.01. After solving this, we will get this. So it means that sequence is Cauchy sequence, and definition says that their distance should be less than 0.01 epsilon value. Then that sequence is Cauchy. So this means that this sequence is Cauchy. If we find any number n and m whose difference or distance is less than epsilon, any value of any greater than 0 value of epsilon, then that sequence is Cauchy. So we have shown that sequence 1 over n is Cauchy. So sequence is Cauchy. But we prove the sequence with another method to show Cauchy. Just by that method, I have tried to told you the definition of the Cauchy sequences and how to prove them Cauchy. I have just told you. I have just tried to told you the definition. I have tried to told you the definition of the sequence that are Cauchy, but we prove it by another method, and proofs are very easy if you want to discuss about them. So basically, the first proof is here to first theorem, or you can say first proof is here. Here is the first theorem about that. Theorem is like that. If x is equal to xn is convergent. Now it is given that sequence is convergent. Sequence of real numbers. Of real numbers. Then x is Cauchy. Then x is Cauchy sequence. So we have to prove that x is Cauchy sequence. For that, we are given that xn is Cauchy, xn is convergent, and also we have to prove that we have to just prove that it is Cauchy sequence. So you know that if sequence is convergent, then we will prove like that. If sequence is convergent, then in that its limit exists as sequence is convergent. So limit x approaches to infinity, xn exists is equal to x exists, then so limit exists, then the difference of the limit and the nth term of sequence should be less than epsilon. So then let limit as it is given that limit is equal to x, then for all epsilon is greater than 0, there exists, it is by the definition of limit, n of epsilon belongs to n such that xn minus x, the difference of limit and the nth term of the sequence, should be less than epsilon by 2 for all n is greater than equal to capital N. It is by the definition of limit, as limit exists. So by the definition of limit, the difference of xn minus limit should be less than epsilon, which is equation number 1. Because you know that epsilon is any arbitrary number, and we can write epsilon by 2, we can write epsilon, we can write any epsilon. So why we are writing it here, I will tell you. Because we have to prove that the difference of nth term and mth term is less than epsilon for all n and m is greater than equal to h. Now we have to show what? We have to show that x is Cauchy. So to show x is Cauchy sequence, that for all epsilon is greater than 0, we have to show there exists h of epsilon belongs to capital N such that distance between xn and xm term is less than epsilon. We have to show that for all n and m is greater than capital H, and we have to show like that. To show that, we have given that xn minus x distance is less than epsilon by 2. So if the distance is less than epsilon by 2, then we can know, we shall write that the distance of mth term of the sequence is also distance of mth term, and limit can also be less than any positive number epsilon by 2. So if m is another term of the sequence, then we can write so if n and m are numbers greater than equal to n, then from 1 xn minus x is less than epsilon by 2, and xm minus x is less than epsilon by 2. So we are given these two things. Okay, so we are given these two things which are very necessary to discuss. Now let's move toward so in the Cauchy sequence, we have to prove what? We have to prove that if a sequence is convergent, then it is Cauchy. So to prove Cauchy, we have to show that distance of xn minus xm is less than epsilon, any positive number epsilon. To show that, we can write xn minus x. We can add and subtract x in the mod. So we can write x minus xm in the mod. So we can we know that if we open the mod like that, xn minus x mod plus x minus xm mod, the right hand side will be greater, because if we open the mod, right hand side will be greater. So we also know, if we take minus common, we know that x mod is equal to minus x mod, and if we write like that, x minus xm mod is also equal to, after taking minus common, we can write xm minus x mod is equal to xm minus x mod. So these all threes are equal. So we can write like that xn minus x plus, at the place of this we can write this xm minus x mod. So we know that what is the value from equation 1. So value of xn minus x is less than epsilon by 2, and xm minus x is also less than epsilon by 2. So what is left hand side, it is xn minus xm mod. So this will be 2 epsilon by 2, and 2 is cut with 2, this will be epsilon. So it is shown that the if sequence is Cauchy, then their limit is less than epsilon by 2 for all n and m is greater than equal to h. So it is Cauchy. So it is Cauchy sequence. See you in few minutes. Now we have to show that Cauchy sequence of real number is bounded. So it is given that a sequence, it is a theorem. In that theorem we are going to prove, theorem is here, and in that theorem we are going to prove that Cauchy sequence of real number is bounded. Sequence of real number is bounded. So to show bounded, we have to show that it has lower bound, it has upper bound, it has supremum, it has infimum. And to show that, we have to just show that xn, for example, if we want to show that xn is bounded, then we have to show that xn is less than any number, less than equal to any number. So it is given that sequence is Cauchy. So let's try to prove it. So if we are going to prove, then we will suppose here that x is Cauchy, and it is given that x is Cauchy. So if x is Cauchy, then actually if x is a Cauchy sequence, so if x is a Cauchy sequence, so for all epsilon is greater than 0, then by definition of Cauchy, there is this positive number epsilon, and difference of any two number in the sequence is less than any positive number epsilon. There exists h of epsilon belongs to capital N such that for all n and h is greater than equal to capital H. So it is given that if any positive number, we have xn and we have another number xh whose sum is less than epsilon, and let us suppose that epsilon is 1, because epsilon is greater than 1, so we can suppose epsilon is 1, because we can take epsilon any number. So let us take epsilon is equal to 1. If we want to take epsilon is 1, then we have to show that it is bounded sequence. So also then xn minus xh is less than 1, and also we can write xn minus xh is less than xn mod plus xh mod. So these are basically less than 1, and we can also write, that xn mod is less than 1 if we shift this xh mod on the right side. Then this will become xh mod for all n and h, m is greater than equal to h. So we are supposing here now, let m is the set of those numbers which are greater than x mod x h minus 1 mod xh plus 1 mod and 1 minus xh mod. So let we have supposed that m is equal to the number that are greater than x and mod. So then we can write m at the place of this number because this is equal to m. So we can write like that, then x and mod is less than equal to m for all n belongs to capital M. So x is bounded sequence. Okay, this is shown that x is bounded sequence. So now x is bounded sequence. It is given like that x is bounded sequence. Let us show a question which is not Cauchy. Let us have a sequence which is not Cauchy, and we have to show that it is not Cauchy. If a sequence gives different values of epsilon, then it is not Cauchy. Let we have a sequence. The sequence 1 plus minus 1 power n is not Cauchy sequence. We have to show that. Solution is here. Solution is here. How can we prove that? Let xn equal to 1 plus minus 1 power n is the sequence. Let take epsilon equal to 2. Let us take epsilon is equal to 2. If we take epsilon is equal to 2, then let us take epsilon is equal to 2, and n is greater than h according to the definition. So m is equal to n plus 1 because we have to show that it is Cauchy. So then we can write xn minus xm is equal to xn minus xn plus 1, and if it give us different values, then it is not Cauchy. How we will show that it gives us different values? Let's show it. So let's put the value of xn. What is the value of xn? This is the value of xn. 1 plus minus 1 power n. Let's put the value of xn plus 1. If we put uh, n plus 1 at the place of n, then we will get 1 plus minus 1 power n plus 1. Then we will get 1 plus minus 1 power n minus 1 minus minus 1 power n. This is cut with this. Then we will get minus 1 power n minus minus 1 power n plus 1. And then now this minus 1 depends upon n and n plus 1. So if we put, if n is even, then if we take any even power of n, then we will get xn minus xm mod equal to 1 minus into minus 1, it will be 2, and we have took epsilon is equal to 2, which is not less than 2. So it gives us, now it is giving xn minus xm is equal to 2. If n is odd, then xn minus xm is equal to like that, minus 1 and minus 1. Then this will be again 2, and 2 is never less than 2. So this is not a Cauchy sequence. This is not a Cauchy sequence, and we have proved like that. So we can have the hint from that why it is not Cauchy, because we have seen that we have recently studied the theorem. It is not convergent. Why it is not convergent? 1 plus minus 1 power n. If you put even values, you get different answer. If you put odd values, you will get different answers. So its limit does not exist. If its limit does not exist, it means that it is not convergent. And how it can be Cauchy? So it is not Cauchy. So for this we have took epsilon is equal to 2, and 2 is never less than 2. So this is proof that it is not Cauchy sequence.